Hello YouTube. Today we're going to be doing more differential equations, and we're going to do an example as well as focusing on how to convey what differential equations mean by being clear, concise, by writing in sentences, which might sound abstract or unfamiliar to many people who are in mathematics in primary education, even secondary. Why don't we jump into a scenario and I'll go into further detail. So we have this system, a scenario given here. I drew a tank here, and it's a 1,000-gallon tank, and there is some rate at which a chemical at a concentration of 0.01 grams per gallon is flowing in at 300 gallons an hour and coming out at 300 gallons an hour of the whole thing. So what happens is a chemical, say some toxin or something, is polluting this 1,000,000-gallon tank, and then everything is mixed evenly, and then 3,000 gallons per hour of liquid comes out, or 3,000 gallons comes out per hour from the tank here. So let's describe this scenario in terms of mathematics rather than just jumping in and plugging in formulas. So let's let Q of t be the quantity of chemical in the tank as a function of time. So time t, which is in minutes, and we can describe the rate of change of which this chemical is entering and leaving. So we'll say the rate of change of Q is the difference between the rate in which the chemical flows in and out, which we'll denote as R in for rate in and R out for rate out, respectively. Now, this is a wonderful way of conveying information in like one sentence instead of like two or three. You could say, oh, R in represents the rate at which chemical is flowing in, and R out represents the rate at which chemical is flowing out. But by using this word respectively, you can narrow down the sentence structure here to be more clear and concise. So, writing tip there for literacy in mathematics. Going on to the problem, though, how would you describe this systems in terms of a differential equation? Well, you would say that is to say the rate of change at which Q is changing is the rate in minus the rate out. So, since the rate in can be written as the stuff coming in, so we're trying to figure out how much chemical is coming in. Well, we know the concentration is 0.01 grams per gallon, but how much of it is coming in? Well, that's 300 gallons per hour. So multiply those two together, and the units cancel, and you should get 3 gallons per hour. So we know, 3 grams per hour. So we know every hour 3 grams of chemical is coming in, and that's what represents Rn. So you always want to start out in mathematics with a word when you're writing up a solution to a system you're solving, because it's kind of just like the notation in being clear. Rather than say, oh, what is Rn again? And you just kind of go back and you say, since Rn, so you say, oh, that means it's been mentioned before. Anyway, since Rn is 3 grams per hour and R out is calculated as some quantity, we don't know what it is. We don't know how much chemical is in there, right? Because we don't know how long this is going to be for. So we're going to represent it by the quantity Q as we previously defined over 1,000,000 gallons over 1,000,000 gallons, right? So that's the concentration, times how much is leaving, which is 300 gallons per hour. Well, we can represent as 3 over 10 to the 4th times Q. And if you look at the units, you will notice that the units are in 1 over hour. Now you might be confused, like, oh wait, that can't be done, it needs to be grams per hour. Well, Q is in grams, so don't get fooled there by the units. Q is in grams, so technically the units are grams per hour. So since R in is 3 and R out is 3 over 10 to the 4th times Q, we can say the rate of change of Q is ddt of Q is 3 minus 3 over 10 to the 4th Q. And that is a complete sentence in terms of writing mathematics. So now we know what the rate of change is. Well, what if I give a scenario? What if a lot of time has passed? That can be expressed as t approaches infinity. Time goes to infinity. What would happen? How much chemical will be remaining? Well, we would know that the rate of change of the chemical would be equal to 0. And therefore, the amount of chemical, Q, can be calculated as follows. So all you do is set dt of q is equal to 0. So we have our previous equation here, which is 3 minus 3 to 10 to the fourth, 3 over 10 to the fourth q. And we're setting that equal to 0. Because after a long time has passed, the rate at which the chemicals coming in and out will be effectively 0. And this can be written as by solving for q. We just show our work and show our calculations, and we notice that, or we can calculate that 10,000 grams of chemical will be in the tank after, a lot of time has passed. So let's just make a note here in terms of like what you can interpret from these values. Notice the initial volume of the pond is related to how much of the chemical is in the pond. So if it weren't 1,000,000 gallons and say we started off with 10,000 gallons, that would change how much grams of chemical is in the pond as t approaches infinity. Now I'd like to make a note as to why we use this method in showing like writing out words and using sentences in mathematics. Because if you were to just combine all our work which we just did into something, it would look like this. Yes, the color coding does make it seem organized as I like to color code. However, it is not clear what Q is. It's not clear exactly what R in and R out is, what scenario this could be applied to. You have no idea on what this system means. It's a bunch of calculations that can be done like by a computer. But you cannot, the goal in using mathematics is to convey clearly to someone that what exactly you are doing in terms of calculating whatever it is that you need to calculate. By having this scratch work like here, yes, you will get the right answer. You'll get they have the correct approach and everything, but it's simply not clear to communicate. It's not concise. As you can see, we defined Q of T here. We defined what the rate in and rate out is. The average, the rate of change is the difference between the rate of the chemical flowing in and flowing out. And we know how to we showed how to calculate R in and R out. And we found a differential equation for the rate of change of Q. And then we proceeded to use that knowledge to see how much grams of chemical would be present in that 1,000,000-gallon tank after a lot of time has passed. And then we determined that the initial volume of the pond actually depends on how much chemical is in the pond initially. So that is mathematics. This is scratch work. So I kind of wanted to convey that in this basic example as also an introductory kind of topic on literacy and mathematics. So I would encourage you to start writing sentences and being clear as like you were wanting to show someone exactly what you were doing rather than really being confused and trying to map out this puzzle. So clarity and being concise is a valuable tool in communicating your work in mathematics, physics, engineering, and science. So I hope this helped as a good video for differential equations and literacy in mathematics.